Welcome everyone. My name is Christine Hertzog. I'm the Managing Director of the Smart Grid Library and SGL Partners, a consulting and information services firm. And I'm happy to introduce to you today Jochen Kreusel, who is the head of the Sector Initiative for Smart Grids for ABB. We'll be talking just briefly today about some of the experiences that ABB has had, specifically around distributed generation. So welcome, Jochen. It's nice to have you here.
Thank you very much.
Well, without further ado, let's just jump into some of these questions here. Now, distributed generation, or DG, can add a lot of complexity to the low voltage grid, and it could in some ways become even more complex than the current management of the transmission grid. So what are some of the experiences that ABB has had in terms of helping utilities adapt their business models to effectively manage and go with these types of changes to the distribution grid?
Well, the first challenge that we saw coming to the traditional utility world was the one the distribution network operators are facing, because they have to integrate all these distributed resources, and they all of a sudden ran into the problem that they need to monitor the secondary distribution grids today in a similar way that they're used to do on transmission level. And when you said reaching the same level of complexity maybe as we're used in transmission, I would say that is a little bit too nice, because we are talking about 2 orders of magnitude more of components, of substations, of nodes in secondary distribution, and 2 orders of magnitude is not a little bit more. It's a completely different world. So how to manage that in an efficient way is clearly a challenge that still needs to be solved. So at the moment I would say we are in a phase where technologies are rolled out, but more in a traditional way, just to solve the issues. But the next challenge is for sure to do that in an appropriate way to make it also a feasible and efficient business case. So that was the grid side. And then we have the side, or the energy part of the business, which is in many parts of the world, and for sure here in Europe, a competitive market where all these resources need to be integrated into new services, new service providers. And I would say there we're still very much at the beginning. Most of the distributed generation that has been deployed so far has been installed by private investors, very often subsidized, so the business case is for sure not sustainable. I think we will need to find more sustainable ones in future, depending less on subsidies.
Have you seen any initial or preliminary examples of how you see the business models evolving in a way that is encouraging?
Well, depending on the legal and regulatory framework of countries, we see some countries where aggregators start to become active, very often at the moment focusing on reducing peak load in the grid, so unloading the grids, but they could also try, of course, to come to a better match of load and generation. What we also see evolving is virtual power plants, building portfolios of complementary distributed resources, and by that bringing them to more attractive markets, such as control markets, by making the portfolio dispatchable. So we see these initial things. Some of them are established, some players are establishing real businesses already today, others are still in the piloting phase, but these are things that are taking place now.
Let's talk a little bit more about virtual power plants, or VPPs, because that's a very interesting way to organize distributed generation. And the initial results seem to be encouraging, but do we have sufficient experience with them to fully exploit their capabilities? What are your initial learnings?
Well, do we have enough experience to exploit the full capabilities? I would say, as we are in a transformation process, and we are surely not at the beginning anymore, but also surely not at the end, I would be very reluctant to say we have experience to exploit all opportunities. We have seen promising results, but I'm very sure that we will learn more in future, we and our customers. Challenges that we also have seen is, one challenge is, and it depends what you want to integrate into a virtual power plant, but it is getting connected to the resources. This is one of the key issues, infrastructure issues, how to deal with distributed resources efficiently, so how to get access to them, not only electrically, that's the easy part because obviously all of them are connected to the electrical grid, but also communication-wise, and that's much less obvious. And the response today in virtual power plants is that you just limit or that you have a threshold beyond which you just don't integrate them. So very small resources are not addressed by virtual power plants. They're focusing more on mid-sized, several hundred kilowatts, for instance, but not a few. So, which means on the other side, most of solar is still excluded from that market, but it needs to be included on the longer term because we see more and more of the generation sector shifting in that direction. So that's, I think, is the biggest challenge at the moment, how to integrate efficiently smaller resources, not only mid-sized ones.
And ultimately that does seem that that is a huge business model challenge more than the technology challenge. It's finding the right service models.
And it's a mix. It is somehow a technology challenge because you need to find the right communication solutions which are cost efficient, sufficiently standardized, secure, reliable. So that is the technology part of the challenge, but the other part of the challenge is the regulatory challenge. So such an infrastructure must be there for all players. And I'm pretty sure that no virtual power plant player would ever roll out such an infrastructure to get access to very small resources. They do today, because there is no systematic approach in most of the countries, I would even say in all of the countries. So they do it case by case by integrating the resources they're working with today, but that leads to the result that the resources need to have a certain size in order to be a business case.
That certainly does make sense, yes. You need to have a certain scale in other ways to be cost effective. That seems that you've already outlined a couple of the challenges here to a timely evolution of today's grid into one that fully optimizes distributed generation, large to small. Do you want to expound a little bit on any of those areas? Like you talked about standards, you talked about security, you talked about having a business model that has some impact in a beneficial way on the bottom line as well as on the reliability of the grid. So, what do you see as the biggest of all those challenges? Is there one that stands out more than the others?
Yeah, I would say it's the one I touched already. There must be an approach how to add a suitable communication infrastructure to the power infrastructure that allows players to easily to connect to it and to build services with the distributed generation. So you can compare that with the internet. We have all these smart devices today which connect to each other, and all of a sudden ideas, business models evolve where handheld providers are all of a sudden cooperating with consumer electronics or the other way around, but this all works only because there is a communication infrastructure, and none of these players has rolled out the communication infrastructure. It has been there first, and then the services and the products evolved around it. And I think we're facing a similar challenge if we talk about really integrating distributed generation, really distributed ones, very small ones, efficiently into the power economies. Then we need to have such an approach, but of course I think we cannot rely on the public internet. It's not reliable enough, secure enough, so that barrier has to be overcome. Yeah. Somehow dedicated, a dedicated channel at least, secure, reliable, robust.
And bidirectional, I would presume, so that you can send acknowledgements that, you've asked me to throttle back or to produce more electricity.
And of course that also requires standards defining all these commands that you have described now. So a sort of standardization of these business models is also required, as we are used to use without knowing the details in mobile telecommunication, where we have a similar situation.
Oh, of course, yes. And the nice thing about standards is you can take your pick. We have so many of them. Anyway, I certainly think that you're right. Communications can be a huge part of this, but let's talk about some of the different trend lines going on. Around the world, costs for residential solar continues to drop, which gives these very aggressive forecasts. Recently, Deutsche Bank gave a very aggressive forecast for solar. Do you see a point in time where there may be more distributed generation that's aggregated together as renewables being a greater source of the injection of electricity into the grid than the traditional centralized sources of power?
Without any doubt. That's the very short version of the answer. And to elaborate a little bit more, we have that already today. Not because costs have dropped below the low voltage end users cost before in those countries where we have it today. It's of course because of the heavy subsidies. But if you go to countries like Italy or Germany, where the installed base of photovoltaic is very high already today, depending on the time in the year we are there already. So in Germany in this year there has been a day where all the renewables together, and as it was in summer, I would assume solar had a significant part in that, were covering 75% of the current load. It's a clear answer, it's more than half. So even if you deduct wind, it's still a lot. So it will be clear, and we have more and more countries where rooftop solar has reached grid parity already today. So I would say from a subsidization point of view, it's out of control now. People will do it, and there is still cost reduction potential. So it will happen. For sure it will happen, and I would even go further say it will happen within the next years. And this will of course turn the world of electricity upside down, literally, because all of a sudden the majority of the generation capacity is connected to the low voltage grids.
Mm-hmm. And of course there's a certain amount of intermittency to this.
Yeah.
So we haven't really talked very much about energy storage, but what is your perspective there? I mean, it's from my perspective, very nascent. It's on the same kind of trajectory, perhaps, that solar was on in terms of expenses being high. Do you see it the same way, or
however, it is story. Even if you would assume there will also be cost reduction, and to be fair, we have seen significant cost reductions in batteries over the past 15 years, and it's still ongoing. But even considering that, it's not the same, because the tricky thing with storage is, beside the pure cost question, is the business model. And you may imagine, I'm very sure that distributed generation will have its place in order to shift, let me say, solar generation a few hours backwards to delay it, or to delay loads in order to match better locally with solar irradiation on an hourly level. But it will be very, very hard to justify any business case for seasonal storage. In fact, I believe it's not impossible. It's not possible, because it will be a storage that is intended to be used only once a year, and it has to be extremely cheap to justify that. And I didn't talk about the question of where to get the sheer volume from that you would also need. So I think this time range storage, we will not. I don't believe in storage, other than natural hydro storage, which always has been there, but limited capacity. And there the grids and the interconnection comes in. So even if we have the majority of generation maybe connected to the low voltage grid, it does not mean that this is local generation, because there will be times when we have huge excess capacities regionally, locally, and in other regions a lack of generation, at night for instance, and then we need to connect these regions in order to be complementary. So even with a very distributed generation sector, there is an increasing need for integration and interconnection, which seems to be a little bit counterintuitive at the first moment, but that's how it is.
Mm-hmm. That's very interesting, and I like your point where you talked about energy storage in terms of how often it's used, because we have that problem now where you have a peaker plant that exists just for injecting power into the grid for a few hours of a year.
It's not a wonderful business model. We see that, and this is a good indication also what is happening now, where the new renewables gaining more and more share and becoming really system critical. And we saw that first with regard to technology. So all of a sudden we saw distributed generation impacting the transmission grids, and now more and more the distribution grids. voltage stability issues, and so that was technically transforming the systems, and now we see also transforming them the business models of all players, more or less, and in particular of the traditional generators. And I think this is still one of the open issues, how to find business models also that address properly that people do not only want to have energy, they want to have energy in time. And in the traditional utility business model, they did not to pay extra because it was not a problem. A conventional power station can deliver whenever it's expected to deliver. So there was no particular challenge in providing electricity when it was needed. But with the renewables it is, and that means this needs to become an extra value, and this is an evolution of the business models, and that hopefully will also solve the peaker power plant issue. But as it is not done yet, they have some problems now.
Yes, yes. We've talked a lot about generation of kilowatts and megawatts, but let's talk about generation of negawatts in terms of demand response. What type of role do you see that playing in the business models and everything we've talked about regarding the complexity of distributed generation?
I believe this is a very important missing link also in the old business models, and in fact we see that liberalized markets are running in that problem even without renewables, the justification of peaker capacity, of reinvestments in peaker capacity. I think one of the reasons is that electricity in the traditional way is one of the very few, if not the only industry where we are used to cover even very rare peak demand situations. No other industry would ever do that. In all other industries, the normal response of the market would be what you have called negawatts. So because it would be too expensive to cover the last very rare peak. And renewables make this even worse because they make the utilization profiles worse. So there are even higher peaks with even lower frequency. So that's why we see it in the renewable markets first. But it's a fundamental issue of electricity markets in general. And I think negawatts can be the missing link here, and it requires that there are business models in the market, and it also requires an adequate technical infrastructure to realize negawatts, to communicate to those that are willing to adjust their consumption, which we don't have in place today. In most of them, in some we have. It starts to evolve, so in some states in the United States it is reality. And it's easier there technically because most of them are vertically integrated on distribution level. In Europe we have the fully unbundled world, which makes it more complex. But yes, it is clearly the answer to the question how to deal with the fact that renewables are not able to provide electricity at any time. And if it is done properly, then there will be a technical infrastructure and also a legal framework that in theory leads to the perfect optimization whether something should be solved on the generation side, for instance by adding storage or a source which is more dispatchable, or on the load side, so to reach the overall optimum. So that's the ultimate target. The other point this question links to, and I'm touched on that already in what I've said before, is that this requires a suitable communication infrastructure again, because if we're talking about demand, we're usually talking about even smaller units than if we're talking about distributed generation. So the challenge to integrate small units in an efficient way into the balancing of load and generation is even bigger there.
Yeah, so as you were talking about that, I kept thinking it becomes a telecom or a datacom problem essentially at some point in time.
And partly solutions may be autonomous. And that's also part of the intelligence that we engineers have to deliver now, to apply now. But yes, it's a challenge of handling big numbers of small units.
Well, it is a different way of machine-to-machine communications, working in a cooperative way around their use of energy. So we're running out of time here, and this has been fascinating. We've spent a lot more time talking about any of these topics. Are there any final points that you wanted to bring out? Anything you wanted to leave the audience with?
Yeah, maybe one thing is, I mentioned before, we are in a transformation of a key industry, in fact the first transformation since it has been involved. But we are in this transformation since some years now. And the interesting thing is if you compare exhibitions like this one where we're in here today with 5-6 years ago, you see a lot of different things. Although it also has been an evolution. If you would have compared it year by year, maybe you wouldn't have seen a big difference. But if you compare it over 5-6 years now, you see a pretty different world. So the transformation is becoming reality. That is what you clearly see. And if you look at, for instance, we are exhibiting here, we have switchgear. We are addressing the secondary distribution issue. So one of our products that also has been awarded, nominated for an award here, is our digital secondary switchgear, which is something we would not have talked about even 5 years ago. And it's one of the urgently needed infrastructure elements today. And the other one, also been nominated for an award, is outage management, which is the software side of playing with the infrastructure. And I think these are two key elements to solve the business model issue for the network operators at least. So it's a nice summary of what's happening.
Well, that's wonderful. Well, thank you so much, Jochen. Really appreciate your time, and thank you as well for your attention.